Device drivers. A device driver is a computer program that controls a particular device that is connected to the computer. So typical devices are keyboards, printers, scanners, digital cameras, and external storage devices. So each one of these need a driver in order to work properly. A driver provides a software interface to hardware devices, enabling operating system and other computer programs to access hardware functions without needing to know the precise details of the hardware being used.
Go.
A driver communicates with a device through the computer bus or the communication subsystem to which the hardware connects. When a calling program invokes routine to the driver issues commands to the device.
Interrupt handlers, also known as interrupt service routine. It's a callback function for an operating system or a device driver. So interrupt handlers determine the causes of interrupt, process it, restores it, and then after restoring it, it executes the return of the process that has been interrupted. So this is the process of an interrupt handler. First is the device driver initiate an I/O. This is the initiated I/O where an interrupt has been generated. When an interrupt has been generated, it will be detected by the CPU, then transferred to the interrupt handlers, where the interrupt handlers will process the data, and then after that process, it will go back to the CPU and resumes the processing part. And then it's a continuous flow of being processed, or every time CPU detects an interrupt, it will just go back here and then go back again. It's a cycle. So this is a simple diagram of an interrupt handlers. This program is in a continuous flow, then suddenly an interrupt happens. Now this interrupt will be caught by the CPU, then dispatches to the interrupt handlers. The interrupt handlers will fix that interrupt, so the program will go back to its normal flow.
So now, let's talk about device-independent I/O softwares. Its basic functions are first, to perform I/O functions common to all devices, and second is to provide uniform interface to user-level softwares. Its functions are the following. First is its functions are the following. First of all, is uniform interfacing for device drivers. So now, let's take a look at figure 1. In diagram A, each and every device drivers have different interfaces to its operating system. While applying uniform interfacing in diagram B, each and every device driver has the same interface in operating system. So, what does that mean? Uniform interfacing makes it easier to plug in a new driver, provided that it conforms to the device driver interface. In diagram B, which buffers in user space, the user provides n character to the user space and then does read on n characters. In diagram C, which buffers in the kernel space. The buffer is created obviously in the kernel space, and the interrupt handler is responsible for putting the characters there. Meanwhile, on the last diagram, the diagram D, this is also called the double buffering scheme. There are two buffers here in the kernel space. Now, the first buffer is responsible for accepting those characters. Once the first buffer is full, it is copied to the user space. And now in this case, it's the turn of the second buffer to accept those characters. And then the cycle goes on and so forth. The next function is error reporting. When an error occurs, it is reported back to its caller. The next function is allocating and releasing dedicated drivers. Some devices like CD-ROM readers can only be used by a single process at any given moment. So, a mechanism is required to request and release dedicated devices. In this case, a queue for those processes is required. And the last but not the least is providing a device-independent block size. Different drives may have different sector sizes. It's just up to the device-independent I/O software to assign them device-independent block size with higher layers.
So lastly, we're going to be talking about the kernel I/O subsystem. So this is the one that provides several services that relate to the I/O. I'll be giving 5 examples of these said services. The first one is scheduling. So this is done because it can improve the overall performance of a system. So how does it do it? The kernel does it by scheduling a set of I requests and determining the best way to execute them. So by doing this, it can reduce the average waiting time, turnaround time, response time for the I/O to complete. So it is quite familiar with us. It is the first come, first served, the shortest job first, priority, round robin, and multi-level queue scheduling algorithm techniques, whether they may be preemptive or non-preemptive. So the second one is buffering. So a buffer is a memory space that temporarily holds data that is being transferred between two devices or a device and an application. So this is done to cope with some speed and size mismatch between the sender and the receiver. So the third one would be caching. So cache is a region in fast memory that holds a copy of original data. So this is done for easier and faster retrieval of data as compared when it is being retrieved from the original file. So the fourth one is spooling and device reservation. So spooling means simultaneous peripheral operation online. So this is a type of buffer that holds jobs for a device until the device is ready to accept another set of operation or process. So the last one is error handling. So this is used to guard against many hardware and application errors by using protected memory. So a complete system failure may be prevented or avoided. As a result of minor mechanical glitches or any failure that may occur during I/O transfers. So for a clear comparison between buffering, spooling, and caching, so buffering is a limited area in main memory. It carries original data. It is used to cope with different speed or size between sender and receiver. So for example, there's a fast CPU and a slow disk drive. So spooling uses disk as a huge buffer. So it is also handy to schedule tasks, example when printing. So while as caching is located in the processor itself, it holds copy of original data and stores copy of original data for easier and faster access for repeatedly used data.